This is the Building Automation Monthly Podcast with Phil Zito, episode 117. Hey folks, Phil Zito here, and welcome to episode 117 of the Building Automation Monthly Podcast. And in this episode, we are going to be continuing the three-part series on how BACnet integrations really work. And we are going to be diving into BACnet MSTP, or Master-Slave Token Passing. If you haven't listened to episode 116, part 1 rather, of this three-part series, then you're really going to want to do that. Otherwise, a lot of what we cover probably won't make sense. You know, back when I was in the field, BACnet was one of those things that just kind of worked. And for the first couple of years of my career, I really didn't understand how it worked. And that probably cost me a lot of time because I made some mistakes that could have made my networks more efficient, could have made troubleshooting a lot easier, could have just made life in general better. But you know, it's kind of one of those sayings, you don't know what you don't know. And that's why you're listening to this episode, because you're going to learn what you don't know. And I'm going to help you understand really how BACnet MSTP works. Now, when it comes to installed protocols, BACnet MSTP is arguably the most installed building automation protocol that's out there. And that's because BACnet MSTP has been around really for the longest amount of time. And what we see with BACnet MSTP is a protocol that is essentially bulletproof. I mean, it's not bulletproof, but it's a very simple physical network structure to install. It's got a lot of capabilities built into it. You can daisy chain it from one controller to the next. It's decently fast. It can hold a good amount of devices, and it can run for a fairly long distance. And you can use inexpensive wire to actually implement it. That's the physical side of BACnet MSTP. And then on the logical side of MSTP, you hear master-slave token passing. Well, basically what that means is just like in Ethernet, you have this thing called a frame. Well, you have a frame in BACnet, and that frame is a token. And essentially, when a controller has the token, it can talk on the network. That's how you avoid data being sent from multiple controllers at the same time and having what are called data collisions. Now, more on that in just a second. So what is BACnet MSTP? This is kind of the part where we need to do our obligatory technical knowledge, because if you don't have these basic fundamentals of MSTP down, then when you get to integration and when you get to troubleshooting, it won't make sense. So first off, MSTP is a serial network. It's based off the RS-485 standard. And what that means by serial network is that the controllers are running in series and the bits are sent in series. Actually, the serial network part means that the data is sent in series, okay? And then the daisy chain aspect of it is the physical serial network aspect. So if that totally confused you, let me kind of explain to you, all right? So imagine that you're holding hands with a bunch of people, okay? And everyone's holding hands, and it's a long line of people holding hands. That's a daisy chain. So you're going from one person to the next person to the next person in a row. Well, that's kind of what's going on with these controllers. You have these controllers, and then they are connected to each individual controller down this line, down this daisy chain. And on any given physical segment, you can have up to 32 devices per the RS-485 standard. That may be a little different based on your manufacturer, but the RS-485 standard will say a segment can be 3,000 feet and have 32 devices with 18 gauge wire. And manufacturers may say differently. You can have 50 controllers. Some will say just, hey, until your signal degrades, keep adding controllers. You know, if you stick with the 485 standard, I've yet to see an RS-485 network or segment with 32 devices on it that performed badly as long as it was wired up properly. Now, on the entire run, you can have 64 controllers to what's called a trunk or a field bus. Okay? And so that's the physical aspect. But logically, you still imagine all these people holding hands, standing next to each other. Well, only one of those people can talk at the same time and start passing a message. You remember that old game that you would play in elementary school, and it's where you would know something and then you would pass it down the line, and by the end of the run, or by the end of passing it down the line of person to person to person, it would be like, started off Susie likes dogs, and then it was John eats hot dogs on a train. Somehow the message got completely distorted. Well, that's what we're looking to avoid by this thing called the token. Basically, what happens is when you have the token, you're the only one who can talk, and that message goes all the way down the trunk. It's not stopping at each individual controller, unless it has to for messaging purposes, but that's way outside the scope of this episode. So, like I said, RS-45 is using daisy chain, and it's sending those bits in series down the wire. And then we have what is called baud rate. You've possibly heard of baud rate, depending how old you are. It's an old term that was used with modems. So if you remember 56K baud modems, baud is basically a measurement of state changes. Not on-off like bits. Bits are on or off. Baud is symbol changes, basically. So you can have more than one kind of bit state. You could have a couple bits that are turned on, and that could be one symbol change. It's a confusing topic, but just realize that baud does not match up with bit. You really don't even need to know how to translate the data speeds from baud to bit or bit to baud. That doesn't matter. What matters is that you know that every controller on a trunk is running the same baud rate. This is one of the biggest issues that will cause network problems on your BACnet MSTP networks is baud rate mismatch. So everything needs to be running the same baud rate. And by the way, 9600 or 38400, those are the two required baud rates that every controller is required to support per the standard. Okay, so we've talked about the physical kind of layout, we've talked about speed, we've talked about logical communication utilizing a token, which we'll go more into tokens in just a second. Now we're moving on to this topic called MAC dip switches. So what are MAC addresses and what are dip switches and what do they have to do with one another? Well, just like with Ethernet network interface cards, you have MAC addresses, which are hexadecimal numbers. You have 255 addresses that, well, technically there's 256 addresses that you can use within building automation MSTP trunks. And what those are the physical addresses of these controllers. Now, how this is typically set is you have a dip switch on a BACnet MSTP controller, and this MSTP controller's dip switch is set basically using binary math, where you turn the switch on and each switch symbolizes a number 1, 2, 4, 8, 16, 32, 64, and 128. And as you flip those switches on, those switches then go and indicate a address. You basically add them up. And those are the physical addresses of these controllers. And this is really important. This topic I'm going to spend a fair amount of time on in this episode because how you address your controllers is going to make a huge difference to the speed of your network, the ability to troubleshoot your network, the ability to organize your network. So some folks, what they like to do is they like to go and run their trunks with a supervisory device kind of in the middle and then have one BACnet trunk running off to the left and one BACnet MSTP trunk running off to the right. I'm personally not a fan of that because it doesn't really position you well to take advantage of kind of one of the most powerful things, which is a token. If you study the ASHRAE 135 standard, which is the BACnet standard, which I had the incredible pleasure of reading all 1,100 or 1,300, depending on which standard you read, pages of that standard for my BAS protocols course. I really wanted to make sure that course dialed in on everything you needed to know about protocols in order to succeed in building automation. So I read the standard, and then I made the standard actually understandable in the course. But part of that is you see the state machine for BACnet MSTP. And if you're like, what the is a state machine? Well, basically, a controller can be communicating, the BACnet MSTP card can be communicating in one of 9 states. And it can be waiting for a token, it can have the token, it can be going and sharing itself to the network, etc., etc. Well, as you learn how the controller then gets rid of the token and passes it on to the next controller, well, it normally goes in sequential order of the addresses. That's why if you address your stuff 1, 2, 3, 4 in sequential order down the trunk, it makes your network a little bit faster. It also makes it a lot easier to troubleshoot, because the beauty of BACnet is that even if a controller goes down, typically the trunk will keep communicating. And if you know it's controller 1, 2, 3, 4, 5, MAC address wise, and you know address 5 is down, then it's pretty easy to follow the trunk and figure out where the controller is, even if you don't have job drawings. It just makes it a lot easier to troubleshoot. So there's a lot of benefits to addressing, and that's what I teach in my design courses, to address sequentially, especially when you're dealing with BACnet. Things like LAN and Modbus, I was about to say Nodbus. Modbus don't matter quite as much, but Modbus RTU matters, but TCP IP obviously not so much. Okay, so as I was saying, you have these MAC addresses and you set them with dip switches, but addresses 1 through 127 can be either master or slave devices. So if you recall from the previous episode, which I told you, this episode ain't gonna make sense if you didn't listen to episode 116, so go listen to it. All right. But as I was saying, episode 1, I'm all excited. I've got this standing desk and I'm standing and talking right now instead of sitting, and it gives me so much energy. I've become quite the little butterball since getting out of the military and having a sedentary? I can't even pronounce that word for the life of me. Sedentary is a job where I sit a lot. All right, there we go. And so standing is one of the ways I'm combating that. Anywho, as I was saying, so you've got these MAC addresses, and addresses 1 through 27 can be master and slave. So master devices allow you to initiate service requests and execute service requests, whereas slave devices can only execute service requests basically in response to a service request that's initiated by a master device. So slave devices are fairly useless. I know it's kind of not something a lot of folks talk about, but it's just not something that's very useful. If I had to choose to pay a little bit more to have a master device, I would, because it gives you more capabilities. Now, with that being said, these master devices are going to be our primary focus as we work with BACnet MSTP. So we're going to be focused on the master devices because those are going to be what are initiating and executing service requests. So remember, our service requests are read property, write property, who is, I am, all that stuff. Now, there is also 255, address 255, which you never want to set to 255 because 255 is the broadcast address, and that is how the controllers actually identify themselves on the network, so that way the controllers know where to send the token to next. And once again, is an important reason for us to have our MAC addresses sequentially down the trunk, because we want to send it to the next one. And if we're 15, we want it to send it to 16, and we don't want 16 all the way at the end of the trunk, okay? So it's really important for sequential. As I mentioned with the token, that allows us to communicate, allows us to initiate our service requests. Now, we can respond even if we don't have the token. So especially if a controller sends some information to another controller and it needs a response, it's a complex acknowledgement or just a simple acknowledgement for BACnet service, then the controller can respond even if it doesn't have the token. Because nothing else should be communicating because the controller that initiated the response has the token and it's waiting for, or initiated the service and it's waiting for the response. All right. So that is the physical kind of aspects of BACnet MSTP. There is one more thing, and that's called the end of line. So what we do is we basically introduce some impedance, which is a fancy way of saying resistance, by putting a 120 ohm resistor at the end of the line. Some manufacturers' controllers will actually have an end of the line dip switch. Others, you'll just go and put that resistor on, and you want to end a line on both sides of the trunk. That way the trunk knows where the lines end. And once you have end of line, then that will keep the controller from trying to communicate further than that. There's also repeaters, which allow you to, up to 2 segments, allow you to extend your segments. So 1, 2, 3 segments total. And that allows you to hit right around 9,000 feet. Some manufacturers will say that you're able to go up to 15,000 feet. It just depends on kind of how you're doing the wiring. It also depends on the manufacturer's controllers, things like that. Okay, so there you have it. That's the physical stuff. Now, how do we actually tie in? One of the selling points with BACnet MSTP, I remember hearing this quite a bit. You don't hear it as much these days because everyone's all IoT, IP controls, cloud this, cloud that. But back in the day, and when I say back in the day, it was actually like 2008, everyone was all, hey, our controllers are BACnet MSTP, and because you have BACnet MSTP controllers, you're not locked to one manufacturer. You could just go throw someone else's BACnet MSTP controller on the trunk and be good to go. And technically that's true, but how do we do it? Well, that is why I have my 5-step integration process, actually 4 steps. I'm seeing double. I need to get some new glasses here. They actually have my glasses at the optometrist. I need to pick them up. But it's actually 4 item list. So the 4 items, first thing we want to do is we want to determine where are we going to put this device. Now, if we followed our addressing sequentially, then in an ideal world, we're going to go and put our controller at the end of the run. But sometimes that's not an ideal world, right? Sometimes we add a VAV box and now we need to go and add a new controller. Well, there's kind of 2 ways of doing this. There's the low cost way, which is you simply split off your trunk. Remember, we can't do T-taps. We can't just tap off of a trunk. We have to make it a continuous daisy chain. T-taps are very bad for BACnet MSTP. So what we'll do is we'll interrupt the trunk, let's say between controllers 15 and 16, and we'll run it to the new controller that's nearby, and then we'll run it back to 16. So we're keeping that continuous daisy chain. But what do we address? What do we do? And that's a strategy decision we have to make. We can put a higher address. We could put maybe 35 or 36, depending on what controller address we do last. Realize that it's going to slow your trunk down a little bit, not a ton, but a little bit. And it's going to make troubleshooting a little bit more difficult. Or you can continue, you can readdress all your MAC addresses, which means you're going to have to most likely rediscover your devices into your tree. You're probably going to have to do some point rebinding, but that's the ideal way. I'll be honest with you. Normally on retrofits, if it was just 1 or 2 controllers, I would just go and continue on from the last MAC address used. If it's way more than that, then I would seriously consider going and readdressing. It's a pain in the butt, but it's the right thing to do for the customer, and it makes it a lot easier to troubleshoot. Now that you've done that, right, we've determined where to put the device, we need to physically make sure that the baud rates match. We need to make sure the wiring matches up. We're using the same gauge of wire, especially if this is a customer who's doing some kind of value engineering strategy and they're like, oh, I'm going to bring in mechanical or control SI ABC, and they're going to add their controllers now, by the way, too. Well, you want to make sure those controllers those installers use the same wiring strategy. They use the same wiring as close as possible. You don't want to introduce unnecessary variables and changes. You also want to pay attention once again to the MAC address. Then you need to work on the logical device ID and network ID. You need to make sure that it's on the right network ID, because BACnet MSTP has its own network ID. And you want to make sure that the device ID is unique. So we have a unique logical device ID for that network segment. Then finally, we add that, we go and we run our discovery, which executes the whois service. The whois service finds that device. The device responds with I am, giving all its BACnet details. There's a dynamic constructor which adds that device to your trunk, essentially. It discovers that device, you click add, it adds it to your trunk, and there you go. That's a BACnet MSTP integration. Not really that complex. The variables in play are wiring, baud rate, MAC address, device ID, and network ID. We want to pay attention to those variables because that is going to impact our integration. Now, when we get to BACnet IP, there's going to be a lot more complexity that we'll cover in next week's episode, where we talk through things like different subnets, different networks, different ports, all those kind of variables that come with BACnet IP. But MSTP, pretty easy. Now, troubleshooting. So how do you troubleshoot BACnet MSTP? You know, I was in the military. I worked on missile systems. I know how to use oscilloscope. I know how to do metering. I know how to run out comm errors. But the first thing I do when I have MSTP issues is I don't stick a scope on it. I don't sit there and start metering it. That's not what I do. I go and first thing I do is the duplicate check. Does it have a duplicate MAC address? Does it have a duplicate device ID? Those are kind of, and the reason I do this is because the likelihood of grounding, the likelihood of bad signal shaping, that essentially that's where when you look at an oscilloscope, it looks more like an AC wave and less like a digital wave. Just bad signals, that is less likely than device ID mismatch or duplication, MAC address duplication, baud rate mismatch. Those are the things that you really want to check up the front. So if I were to put these in order and you called me to a site and you said, Phil, my trunk is being flaky. First thing I would do, I'd say, where is it being flaky? Is it being flaky everywhere? Is it when it gets to a specific device? Because if it gets to a specific device, that tends to indicate, but yet it can still communicate, that tends to indicate either some form of wiring or baud rate mismatch at the device. If you get to a device and then the entire trunk stops, that tends to indicate a duplicate device ID or a duplicate MAC address. So those are kind of your two signs. Also, another one I've seen happen is end of lines. If you have a trunk and it's working just fine, and then you replace the controller and all of a sudden at that controller, you can't see anything else down the line, usually that means someone accidentally either crossed polarity of the wires, meaning they put the positive on the negative and the negative on the positive, or they went and turned on the end of line on accident. And those are some things to check. Now, if you've done all of that and you're still getting some flaky stuff, that's when you can do voltage testing. You can make sure that you've got your manufacturer's recommended voltage. You can do oscilloscope, making sure that your signals are actually forming and shaped the way they're supposed to be. You can also do resistance check-ins to see for impedance. You can check the shield, make sure that that's properly terminated and you're not getting EMF. You can look around the device, see what's going on. I've seen motors actually go and interfere with wiring that wasn't properly shielded or the shield wasn't terminated properly. So you've got those aspects. There's a lot to it, but if you stick with the duplicate MAC address, the baud rate mismatch, the bad wiring, the duplicate device IDs, the end of lines, that will pretty much carry you home for most of this. So this was a little shorter of an episode, but BACnet MSTP, it's been around for a long time. And if you've been in the field for any amount of time, you've gotten pretty comfortable with it. Just remember, it's a daisy chain protocol. Things follow one after the other with unique MAC addresses and unique device IDs. You want to match your baud rates. And then when you are going and adding a new device, you simply go determine where that device is going to go, make a MAC addressing strategy decision, check your baud rate, check your wiring, check your device IDs, make sure that's all good, and then do your device discovery and map that sucker in. And that, my friends, is BACnet MSTP. Okay, so what do you do from here? Well, first off, all the notes and anything that I referenced will be found at buildingautomation.com/117. So if you want to get links to previous podcast episodes, if you want to check out our free courses, if you want to check out our premium courses, go to buildingautomationmonthly.com/117. Next up, we're going to be covering BACnet IP in next week's episode. We've been diving pretty deep into the BACnet protocol. It's a pretty important protocol. If there's something you'd like discussed in next week's episode, then go into the comments section below this recording and leave a comment and say, hey, I'd like you to cover this. If I receive it prior to recording next week's episode, then I'll do that. If you're listening to this in the future, well, drop a comment in the comment section. Love to see your questions and thoughts. Final thing is subscribe. Subscribe to the podcast. Every week we come out with new podcast episodes. We're up to episode 117. No other podcast out there dives as deep into building automation as we do. And we cover all sorts of different aspects of building automation. So if you want to make sure you don't miss a single episode, then go to iTunes, Stitcher, Google Play, whatever podcast player you use, and subscribe to the episode so it automatically shows up in your podcast listening software. With that, thank you so much for listening to this episode. Depending on when you're listening to this episode, our Protocols Bootcamp course may or may not be released. And if it is, I really encourage you, if you found these past episodes on BACnet to be very informative and you'd really like to have a solid education on the top 3 BAS protocols, BACnet, LAN, and Modbus, then I encourage you to go and enroll in that program. You'll see a link at the bottom of the page at buildingautomationmonthly.com/117. If the course is open, then that link will take you to the sales page. If it's not, it'll take you to the wait list. I'd encourage you to pick that up. This is a topic I wish I'd learned very early on in my career. With that being said, thank you so much. Look forward to talking to you again next week. Until next week, take care and continue to learn more, because your knowledge of building automation is the most powerful tool you can have in your career. Till next time, take care.